Okay, this is 3.2 part 2, just because we don't want the video getting all too long here. So this is dealing with trinomial patterns, and a newer concept that probably wasn't taught last year, but is very, very useful and a bit of a shortcut to make your lives significantly easier when things come around. So if you haven't seen part 1, go back and watch part 1. This is simply part 2 for that. This will be an example 4. So what we mean by a trinomial pattern? When you see a trinomial, a lot of us forget the fact that if I have things in my bracket, a binomial in my bracket, this can still be considered a trinomial expression, even though my variable is in fact a binomial. Right? This we can factor the exact same way we can factor our normal trinomial. What you do want to make sure you do is think of your x plus 2 as a actual, oh sorry, these have to be the exact same, so we'll make these both x plus 3. There we go. As long as these two terms are the same, you can treat it as one variable. So in fact, if I were to rewrite this, I'm just going to say that x plus 3 is going to equal some variable. So let's go with, I don't know, t. We're going to say make it equal a variable. So if I rewrote this, what would happen is I have t squared minus 6t minus 16. And this, you guys can probably recognize, is a simple trinomial. We can factor this way back from, grade 10. Two things that multiply negative 16 and add up to negative 6. And once we've factored that, we're going to find the two factors and then replace our t again back with our x plus 3. So, two things that multiply to negative 16 and add up to negative 8. I believe that should be, well, it looks like negative 8 and 2. So, a simple trinomial, we don't have to worry about the coefficient, which is nice. So we just go t minus 8 times t plus 2. However, we now replace t with our x plus 3. So t minus 8 really becomes x plus 3 minus 8, and this whole thing is times x plus 2, sorry, x plus 3 plus 2. Make sure we keep everything in line here. And because they're simply adding along, we simply go x plus 3 minus 8, well, 3 minus 8 is x minus 5 times 3 plus 2 would give us x plus 5. So really the shortcut here is just simply, if you see something that looks like a trinomial pattern, don't worry about what's inside your brackets, replace it with some sort of variable, solve it normally, and then once you've done that, pop back in what you replaced and go from there. They're pretty easy to do. The very last term we want to talk about is difference of squares. Difference of squares should have been covered last year. It's a huge shortcut to make your life significantly easier with dealing with a special case of factoring. In fact, I think in grade 10 they even call it, special cases involving factoring. But difference of squares is very useful. We touched a little bit about it from chapter 1, chapter 2, but we'll go over it just in case, just because you really want to understand this. Basically, when you're dealing with a perfect square, or difference of squares, your first term and your last term are considered perfect squares. So I've got 4x squared minus 25y squared. And as soon as you see something like this, it should ping right off the bat, wait a minute. 4 is perfect square, 25 is perfect square, x squared, y squared. Hang on, difference of squares. So the shortcut with this is you just take what's the square root of 4x squared? Well, that's 2x, and what's the square root of 25y squared? Well, that's 5y. Now, the only real difficult part of this, when it comes to difference of squares, is knowing what symbols, positive or negative, go in between. And for that, we more or less look at your middle term. Right? So for symbols, we look at our middle term. And in fact, before we do that, I'll give you the other two examples or two possibilities we could have. Because we could have 4x squared plus 20xy plus 25y squared. We're also going to have 4x squared minus 20xy minus 25y squared. And each of these, when you solve them, again, you're going to start the exact same way. 2x 5y, 2x 5y, because this part doesn't change. However, your symbols now do matter. So the easiest one is if there's nothing in the middle. We don't have any sort of xy term. Right off the hop, we know that one has to be positive and one has to be negative, because when I expand this out, those two middle terms, I'm going to have negative xy and positive xy. They're going to cancel out, so I'm going to have no middle term whatsoever. If I have a positive center and a positive last term, they have to be a positive and a positive. If I have a negative and a negative, then my middle terms have to be negative and a negative. You'll be asked once in a while as a trick question. Sometimes they'll give you an equation like 4x squared minus 20xy plus 25y squared. They'll say, why is this impossible? Well, if I have a negative middle term, my last term has to be negative. It's kind of a bit of a trick question. That's difference of squares. It's super useful, super easy. As soon as you see perfect squares, stop right there. Don't try to do this the long way. It is possible, but it takes a while. Your homework for this is on page 194, and it's going to be questions 3 to 7 AB, question 9 AB, 10A, 11D, 12AI, just the first one, and 15AII, so the second one of A. Again, if you have any questions or concerns, please fire me an email. I should be in very, very soon. Good luck.